Welcome to helpyourmath.com. In this video, we're gonna discuss about finding the data value, right, for the percentile, right, percentile's data value using our formula. Right, a couple of things we need to know. N is the total number of value, the L is the locator. And the pk, right, p sub's value of k is the kth percentile, and we use actually the k to locate. We use the k to locate the kth percentile, which kth percentile shows that, well, the pk is a cutting value for the lower k percent of the data with the the remaining percentage of the data, right, remaining part of the data. And to find the value of pk, we will using the counting number and use L to find what number we need to count to. Right, that's the best logic over here is k over 100 times n, which is k percent of, turns the percentile into decimals, then multiply by the n value, shows us which one is the best appropriate, most appropriate location, right? Where is it actually the best place? Right, the steps to find it is arranging our data first. In the increasing order, or in other words, ascending order, right? Then the second one is compute the number L. Use the information we grabbed from the question, right? And the data set itself. And the third step is a little trickier. We need to determine, right, different cases is it actually matters, right, if the L locator is a whole number or not. Right. If it's not a whole number, which means it's a decimal, we round up to the next whole number, and that is our locator, right? So for instance, after calculation, we found out L is 2.05, let's say, or 2.25. Right, let's say, for instance, we get a sort of calculation and find L is 2.25. We just round that up. to be 3. Then whichever k we're looking for is the third value of the well-arranged data set. Right? It doesn't mean the 3 is the number of the data value. It means it's the third value of the data set. We need to go back to the data set and count carefully, after it's arranged, of course, count carefully which number is the third one. Right? Then that's our pk. And if the locator L, after calculation, actually is a whole number. Take the arithmetic mean of L's and its next one. Right, so when we get a whole number, if our L we find is 5, right? That's a whole number. We don't need to do any rounding, right? But the thing is, we need to take the mean, go back to the data set to find what is the L's, what is the L plus 1's data, and then the percentile, whichever the question is asking, is the arithmetic mean. Of the 5th and the 6th number, right, in this case. Right, so that is the basic logic or the formula steps to find convert the percentiles. Right, and most likely, right, we are using the formula to find the quartiles, right, 5-number summary. We're going to discuss that later, but that is the thing. So let's see some example. Right? When we get the formula, we'll see how to apply it. Right? Let's say we have a data. Right, 205947831610. That's 11 numbers, right? So, question one is to find probably, let's say, 25th percentile. Right, 25th percentile. What we're doing is to rearrange the number first. It looks like just from 0 to 10, right, whole numbers. Right, so if you want, you could pull out the information, 11 numbers, and we're looking for 25th percentile, so k is 25. Right, for that locator, that formula you could write it. (25th% of the entire data set to have a cutting value of what? Right, that's the question it's asking. Which means to cut the first quarter, right? If you know that already. And 25 over 11 times, 25 over 100 times 11 is 2.75. And we just wrote it here, right, to find the locator. If that's a decimal, right, if that's not a whole number, we always round up. Right, so after a range, we got a good number. Then for the locator, we have a decimal, then round it up. Right, therefore, the value that cuts the lower 25% of the data set is the third number of the data set. That is from ascending order of the data set. 1, 2, 3. We get the value is 2. For another example, it's whatever ordered number, right? That's this one. If we try to find the 50th percentile, literally is cutting the below 50 and upper 50. In other words, is the median, right? Also could be called the second quartile. We'll see that later. So in that data set, well, we have to arrange that first. From 11, looks like, right? 11, 12, 13. Always arrange that perfectly from the lowest to highest. And we see, right, the 8 numbers and the k provided is 50. Therefore, when we apply the formula, k over 100 multiplied by n, that is 50% of the data. Right, 50% times 8, or in other words, 0.5 times 8, that is 4. Right, that one, the locator will not be just the fourth number, right? The percentile, 50th percentile will not be just the fourth number, since here we get a whole number. The 50th percentile is the average. Between the fourth and the fifth. The fourth number is 14, the fifth number is 15. Therefore, the 50th percentile, or in other words, the median, is 14.5. Right, so that's two examples. One is we get decimal for the locator, the other we get whole number for the locator, right? The way we're doing them is a little different, right? So be careful when you do the question. Then the next introduction a little bit is the 5-number summary and the box whisker plot. Right, we have a data set. The 5-number summary, they are the minimum, first quartile, second quartile, third quartile, and the maximum. Right, and it's very easy to understand the minimum and maximum, right? It's the lowest and the highest number in the data set. The first quartile, we just introduced about the percentile, and first quartile is cutting the first quarter. First quarter lowest data to the other remaining, right? So the first quartile is the 25th percentile. And we see the second quartile is the median. Is cut the 2 quarters, that is the lower 50 and upper 50, right? Which is the 50th percentile. In other words, is the median. And third quartile, you can think about it, right? It's cutting the lower 75% and remaining the upper 25%. So that is the 75th percentile. Right? So when we get the quartile turns into percentile, we are able to find the locator and finally find the data, right, what they are. Another thing is the interquartile range, IQR, right, is a way to determine if a given data set, individual data set, has outliers or no. And the outliers are 1.5 times of the interquartile range above third quartile, or any number in the data set that has 1.5 times the interquartile range above the Q3, or 1.5 of the interquartile range below Q1, right? Any number that are too large or too small are called the outlier. Maybe you have seen the other version, right? 2 standard deviation away from the mean, extreme than that, you get the outlier. That is also one way, right? If we using the 5-number summary and together with Whisker plot, the outliers are actually out of that certain range, which is 1.5 IQR above Q3 and 1.5 IQR below Q3. Right, so these two are fence, right? The lower value and the upper value, they are the fence to determine the outliers. Lower fence, upper fence, right, respectively. So that is the way to find the outliers. And of course, for the Whisker plot, we have special ways, right? We need to use all the 5-number summary, right? Then also considering if there are outliers or no. So while 5 number summary are there, if there are outliers, then we use the fence to be the cutting value. If there are not outliers, then we use the regular data set. The fence will be just the regular minimum maximum, right? If some of the value has outliers in that, or if some of the value are outliers, then the graph will look a little different, or will have technique. So, yeah, 5 number summary are there. I could erase some part of it. Right. We have lower fence is Q1. And upper fence and of course then the quotient range will be the difference between third and first quarter, right? Right, so for the box Whisker plot is use a plot, right, to graph the data set using the 5 number summary and fences whether there are outliers. Right, if we have outliers, then we use fence. If we don't have outliers, then just 5 number summary will be good enough. All right, so that's a brief introduction, and we'll see example in the other videos. All right, thank you.